Welcome to True Projects. In this video, we are going to explain about the project titled Improved Vision-Based Vehicle Detection and Classification by Optimized YOLOv4. Our project's primary focus is to create a cutting-edge system capable of accurately locating and identifying vehicles. This system has broad applications, particularly in improving traffic management and enhancing security. To achieve precise vehicle detection, we rely on a sophisticated tool called YOLOv4. We fine-tune and optimize this model specially to excel in identifying vehicles. It's like giving it special training to become really good at recognizing different types of vehicles in images and videos. The ultimate goal of our project is to develop a reliable tool that can quickly and accurately detect vehicles in real time. This has significant real-world benefits. For instance, in traffic management, it helps make the flow of vehicles smoother and more efficient. In security applications, it enhances surveillance capabilities, ensuring potential threats are identified promptly. Overall, it contributes to a safer and more secure environment in various situations, from busy intersections to critical facilities. The core objective of our project is to develop a sophisticated system that excels at two critical tasks: spotting and classifying vehicles with precision. By doing this, we aim to significantly enhance safety and efficiency in areas such as traffic control and security. To accomplish precise vehicle detection and classification, we employ a highly intelligent model called YOLOv4. Think of this model as a supercharged detective specifically trained to recognize vehicles in images and videos. YOLOv4 is known for its accuracy, and we have fine-tuned it further to make it even better at identifying various types of vehicles. To train our YOLOv4 model effectively, we don't just stop at using regular data. We jazz up our dataset with advanced techniques like randomization and rotation. This means we expose our model to a wide variety of vehicle images, each slightly different from the last. This way, our system becomes super accurate at identifying vehicles in all sorts of pictures and videos. The ultimate goal of our project is to create a dependable tool that can swiftly identify vehicles in real time. Imagine a traffic intersection. Our system can quickly recognize cars, trucks, and more, helping traffic flow more smoothly. In a security scenario, it ensures that potential threats are spotted promptly, enhancing overall safety. This real-time capability is the key to making our roads and facilities safer and more efficient in various real-world situations. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. This initial step involves importing essential software packages and libraries. These packages provide the necessary tools and functions required for subsequent tasks in the project. For instance, libraries for handling data, images, and machine learning frameworks may be imported to enable data processing and model development. The packages are NumPy, Pandas, Matplotlib, Seaborn, etc. Exploring the dataset, vehicle detection data. In this phase, the project team examines the dataset specifically curated for vehicle detection. It involves activities like reading and understanding the data, assessing its structure, and potentially visualizing samples from the dataset. This exploration is essential to gain insights into the data's characteristics, which inform subsequent data pre-processing steps. Image processing. First instance. This step focuses on preparing and enhancing the dataset's images. Common tasks include formatting the images into appropriate representations such as blob objects, defining object classes, that is, vehicle types, specifying bounding boxes to indicate object locations, and possibly converting color formats. Loading the pre-trained model. Here, the project integrates a pre-trained machine learning model into the workflow. This model, such as YOLOv4, serves as a foundation for detecting and classifying vehicles. By using a pre-trained model, the project benefits from existing knowledge and expertise in object detection, saving time and resources. Image processing second phase. After loading the pre-trained model, additional image processing may be required to prepare images for model input. This might involve appending annotations to images, converting color representations, that is from BGR to RGB, creating masks to highlight specific regions of interest, and resizing images to match the model's input requirements. Data augmentation. Data augmentation is a critical step in machine learning model training. In this module, the project enriches its dataset by creating variations of the existing images. Techniques like randomization, rotation, and transformation are applied to the images. The purpose is to introduce diversity into the dataset, making it more robust. Data augmentation helps the model generalize better and perform well under different real-world conditions. For instance, it can help the model recognize vehicles in different lighting, weather, or camera angles. Loading the YOLOv4 PyTorch YOLOv4AF. This step involves loading a specific version of the YOLOv4 model, which may have been adapted or customized for the project's needs. PyTorch is a popular deep learning framework, and this module likely loads a YOLOv4 model implemented in PyTorch. Different versions of models may have particular optimizations or tweaks that make them more suitable for specific tasks or dataset. Installing the packages required for YOLOv4 in Colab. This module focuses on setting up the development environment for working with YOLOv4 in Google Colab, a cloud-based computing platform. It ensures that all the necessary dependencies and packages for YOLOv4 are correctly installed and configured. This step is crucial to ensure that YOLOv4 model can be effectively utilized for vehicle detection. Processing the data based on YOLOv4 model. Following the installation of YOLOv4 related packages, this module likely involves further data pre-processing to align the dataset with the specific requirement of the YOLOv4 model. This might include additional adjustment to make image formats, annotations, or other data characteristics to make them compatible with the YOLOv4 architecture. Building the model in Colab. This module involves the actual development and training of machine learning models for the Google Colab environment. Colab provides a cloud-based platform with GUI support, which is advantageous for training complex models like YOLO. Building the model encompasses tasks such as defining model architecture, setting up hyperparameters, and training the model on the prepared dataset. This module ensures that the model is tailored to the project's specific needs. YOLOAF. This refers to the development and deployment of a YOLOv4 based model that may have been customized or fine-tuned for this project. YOLOv4 is a deep learning model renowned for its accuracy in object detection tasks, and YOLOv4AF likely signifies an adaptation of YOLOv4 with additional project-specific features or optimizations. YOLOv4. YOLOv4 represents the utilization of the YOLOv4 model architecture in the project. YOLOv4 is a later version of the YOLO, You Only Look Once model family, known for its real-time object detection capabilities. This module may involve model selection, configuration, and training with the YOLOv4 variant. YOLOv6. While not specified in detail, YOLOv6 refers to a potential exploration or development of a YOLOv6 based model. YOLOv6 would be more recent version of the YOLO model, offering potential improvements in performance and accuracy compared to earlier versions. Faster RCNN, region-based convolutional neural network. Faster RCNN is a different object detection model architecture. It's characterized by its two-stage approach where regions of interest are proposed before object detection. This module involves building and training a faster RCNN model for vehicle detection, comparing its performance with YOLO models. Efficient DET. Efficient DAT is another object detection model known for its efficiency in terms of both model size and computational resources. This module involves the development and training of an efficient DAT-based model for vehicle detection. It's likely explored as an alternative to YOLO models to assess its suitability for the project's objectiveness. Training the model. This module involves the process of training the machine learning models developed in earlier stages. During training, the models learn to identify and classify vehicles based on the prepared dataset. The training process fine-tunes the model's parameters and optimizes the performance to achieve accurate vehicle detection. Building the model with YOLOv4. This module likely focuses on developing and configuring a YOLOv4 based model. YOLOv4 is a specific version of the YOLO model family known for its real-time object detection capabilities. Building the model involves defining the model architecture, setting hyperparameters, and training it on the dataset to tailor it for vehicle detection. Flash framework with SQLite for sign-up and sign-in. This step involves the integration of the Flash web framework with the SQLite database for user authentication and management. Flask is a web framework often used for building web applications, while SQLite is a lightweight and efficient database engine. This module sets up user registration and login functionalities, enabling users to access the system securely. User gives input as image or video. In this part, the project allows users to provide input data in the form of images or videos. This input could be real-time video streams or static images containing scenes with vehicles. The given input is pre-processed and trained model is used for detecting the license plate. Once users provide input data, it undergoes pre-processing to prepare it for vehicle detection. This pre-processing might involve resizing, format conversion, or other necessary adjustments. The trained model such as YOLOv4 is then applied to this pre-processed input data to detect vehicles, including their license plate. The segmented each object and put bounding box. After vehicle detection, the system segments each identified object and draws bounding boxes around them. This step is crucial for visually highlighting the detected vehicles and their license plates in the input data. Final outcome is displayed. The project concludes by displaying the final result to the user. This outcome includes the input data, image or video with the bounding boxes around detected vehicles and their license plate. Users can visually inspect the results, making it easier to verify the system's accuracy and effectiveness. Execution. To execute this project, first we need to open the code folder which contains the project source code file. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path from the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now hit enter. After running the app.py file, the Flask framework will host the application locally at the default address and port. This is the local link. Now copy this link and paste this link into any web browser. I usually prefer Google Chrome and hit enter. The home page of the project is displayed in the browser. This is the front end built using Flask framework. Click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in. This is the login form. Here we need to enter the username and the password which we have registered. So I'm entering the username and the password and click on login. This is the home page of the project. So here we need to upload an image, and after uploading the image, the vehicle will be identified. So now we will choose a file. So I'm uploading the first image. Click on open and upload the image. So here we can see that the vehicle is identified, and we even got the probability score of the car which is identified. Now we will upload one more image and identify the vehicle in the given image. So here we can see that a bus is identified in this image, and we even got the probability score of the bus. Now let us upload one more image and check whether the vehicle is identified or not. So here we can see that a bus is identified in this vehicle, and we even got the probability score. Let us upload one more image. So here we can see these are the buses here which are identified. Now close the image, and the conclusion of the project is: the primary achievement of a project is the creation of a highly accurate system for locating and classifying vehicles. This precision is incredibly valuable in tasks like traffic management and security. Here's why: traffic control. In traffic management, accurately identifying vehicles helps optimize traffic flow, monitor congestion, and detect violations such as red light running or illegal parking. This information is vital for efficient traffic control and reducing bottlenecks. Security. In security applications, precise vehicle detection is crucial for identifying potential threats, whether it's monitoring a parking lot for suspicious activity or securing a perimeter. Reliable vehicle identification system enhances safety measures. We have emphasized the use of sophisticated data augmentation techniques such as randomization, rotation, and transformation to enhance a system's intelligence. Here's how these techniques benefit us. Improved generalization. Data augmentation exposes our model to a wide range of scenarios. For example, rotating images help it recognize vehicles from different angles. This diversity in training data ensures that our system can adapt effectively to various real-world conditions. Robust performance. Randomization and transformation techniques simulate real-world variations in lighting, weather, and perspective. By training our system with these diverse conditions, we equip it to perform consistently well regardless of environmental factors. We have not only built a highly accurate system but also made it practical for everyday use through a user-friendly interface. This is significant because People and organizations can readily use a system without needing specialized expertise. This accessibility means that traffic management authorities, security personnel, or anyone interested in enhancing safety can harness our technology. Our system can be applied in various real-world scenarios, from managing traffic at busy intersections to enhancing security in public spaces or facilities. This versatility makes it a valuable tool for improving safety and efficiency across different domains.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.